Good day viewers, welcome to my channel Mathematics Clinic by Tutor Chris. Alright, in today's video I'll be treating a very essential concept in mathematics which I tag mapping. So these are the fundamentals ideas of calculus. So what do we call a mapping? Before moving on, I would like to tell us that it's not every mapping that is a function. It's not every mapping that is a function. So let's move on. A mapping is a rule that takes one element of a set into another element of a set. Alright, I said a mapping is a rule that takes one element of a set into another element of a set. Alright, you can also say that it's a relationship between two variables. Alright, so in this video I will be making use of variable x and y. Alright, so assuming we are given y equals to 3x minus 2. Okay, so now if you look at this y is standing as the subject of the formula here. So we call this kind of variable, we call it dependent variable. Why we say that x is independent variable? Why? This is what I'm trying to say. If we pick the value of x, let's say the value of x, when the value of x is 1, we are going to obtain y equals to 3 into bracket 1 minus 2. And this is 3 multiplied by 1 will give us 3, and 3 minus 2 will give us 1. Alright, so when the value of x is now 2, we are going to obtain 3 into y equals to 3 into 2 minus 2. And 3 into 2 will give us 6, 6 minus 2 will give us 4. Alright, so when x is now 3, we are going to obtain y equals to 3 into bracket 3 minus 2. And this is equals to 9 minus 2. And 9 minus 2 will give us 7. Alright, what I'm trying to say now is that you can see that when our input, we call this input, the value of x, we call them input. Why this value of y, we call them output. So you see that when we have input 1, the output is 1. When we have input 2, the output is 4. When we have input 3, the output is 7. So this is what I'm trying to say. Whenever you insert real numbers into this function, the output of y for each real number will be different, will differ. So when I'm having 2, I'm having this. Although sometimes, assuming I'm having my y equals to x squared, you know that when the value of x is 1, I'm going to have 1 squared, which is equals to 1. When the value of x is negative 1, I'm going to have y equals to negative 1 squared, which is same thing as 1. This is still a function. But what I'm trying to say is that you can see that this value of y depends on the value of x. When the value of x is 1, we are going to have our y to be 1. When the value of x is 2, we are going to have our y to be 4. You can see y dependent solely on y. So I said on x, sorry. So I said x is called a dependent variable. Y is called a dependent variable. Y x is called independent variable. Alright, that's good. So y is called dependent variable because it depends on the value of x. Why we say that x is called an independent variable. Alright, that's good. And I can say that this y is equal to f of x. You know, I told you in this illustration that the value of x, we call it input. So when I say my y equals to f of x, this is what I'm trying to say. Let's move to example 1. Example 1. In example 1, let y equals to, let's say 2x minus 3. 2x minus 3. What is f of 3, f of 2, and f of a? Alright, so I said y is same thing as f of x. If our f of x, which is a function, because we said that the value of y dependent on x is dependent on x. That's why we said y is a function of x. Alright, so since we said y is a function of x, I can say that my f of x, which is same thing as y, is equals to 2x minus 3. Alright, but if I want to evaluate the value of f of 3, f of 2, and f of a, this means that I'm going to represent the x as 3, the x as 2, and a. So now let's say f of 3 equals to 2x. No, now our x is 3, so I'm having 2 into bracket 3 minus 3. And this is equals to 6 minus 3 equals to 3. Alright, f of 2 now will be equals to 2 into bracket 2 minus 3 equals to 2 multiplied by 2 is 4, 4 minus 3 is 1. So f of a now will be 2 into bracket of a minus 3, which is equals to 2a minus 3. Alright, so this is what I'm trying to say. I hope you get the concept. That's cool. I think we can move on with this. Okay, let's move on. Alright, now guys, I will be showing you another very important thing. I would like you to note. I would like you to note this. Pay more attention to this now. Okay, and it's not necessary that every input, I mean x, that inserts into a function must give you an output which is a real number for y. Alright, but when such happens, we say that the function is not defined at that point. This is what I'm trying to say. Assuming we're having our example 2 now. Let's say example 2. Example 2. And we're having our f of x to be equals to 2x minus 5. 2x minus 5. Alright. Evaluate, or let's say decide the points where the function is not divine, or let's say the function, decide the point where the function is divine. Alright, is divine. Alright, how do we go about this? Our function is saying f of x equals to 2x minus y. Don't forget I said f of x is same thing as y. Alright, so now I can say that this implies my y equals to 2x minus 5. Alright, but for this function to be defined, I said we must have a value for y. That is, the value must be a real number. So if you insert any values for x here, the output y must also be a real number. Once you are unable to obtain a value for this y, that tells us that the function is not divine. Now the question is asking us to decide the points where the function is divine. Alright. If you input 1, you know 1 is a real number, 0 is a real number. If you input 0 here, we are going to have 2, that is when x equals to 0, this implies that y equals to 2 into bracket 0 minus 5, and this is equals to negative 5. When x equals to 1, this implies that I'm having y into 2 into 1 minus 5, this is equals to negative 3. When x equals to negative 1, this implies that my y equals to 2 into bracket negative 1 minus 5, which is equals to negative 7. Alright, what am I trying to say? Wherever the values we insert into this function, we are still going to obtain another value for y. So that tells us that this kind of function is divine or true. So this function f of x equals to 2x minus 5 is divine or true. This function is divine or true. Alright, that's good. So I think I've been able to answer this question. Let's take another example, which I tag example 3 now. Example 3. Assuming now, of course, let's say I'm having f of x equals to 1 over 2x minus 4. 1 over 2x minus 4. And I want to check where the function is said to be divine, when the function is said to be divine. Alright, now if we insert any set of real numbers into this, let's say we start from 1, be it negative, be it positive, we are still going to obtain a value for y, which is real number. But I want to show you something. Look at this now. How to check if the function is said to be divine at some point is that you look for a number in which if you add or you subtract them from this, you are going to have the denominator to be 0. Once that occurs, that tells us the function is not divine at that point. Alright, but looking at this now, you can see that if I insert, that is when x equals to 2 now, this implies that my y equals to 1 over 2 into bracket 2 minus 4, and this is equals to 1 over 4 minus 4, which is equals to 1 over 0. And this is meaningless. This is meaningless. This is meaningless. This is meaningless. It's not possible in mathematics. Alright, we said this is undivine. If you press this to your calculator will tell you math error. So whenever you are dividing any numbers, especially real numbers, with a denominator that is 0, in mathematics is not possible. It will be undivine. So if you look at this now, this tells us that the function is not divine at the point 2. Alright, the function f of x equals to 1 over 2x minus 4 is divine elsewhere except 2. Alright, except 2. So the function is divine everywhere else except 2. Alright, that's good. Okay, so I'll be going to the type of function. I'll be moving to the type of function. Alright, type of function. Alright guys, I would like you to pay more attention to this now. Alright, before moving to that, I want you to look at something. You know, I told you a function is not every mapping that is a function. Alright, so you see what I'm trying to say now. Types of function. Types of function. So the first one is one-to-one function. One-to-one function, which you can also call injective function. Injective function. Alright, I'm also having surjective function, which you can also call onto. Surjective function. Or you say onto function. Onto function. I'm having many to one function. And also the first one I'm having bijective function. bijective function. Alright, all these type of function, they have their properties that make them to be different from the other. Alright, so I will start from one-to-one function. I will break it down in detail so that we understand what we are trying to do. Alright, let's move to injective function, which is same thing as one-to-one. Injective function. Okay, for a function to be injective, every element of the domain must have a distinct image in the codomain. That is, every element of the domain must have a distinct image in the codomain. Distinct. Alright, I would like you to understand the word distinct there, because if you look at the word distinct, that means that it has its own special image. So every element of the domain must have a distinct image in the codomain. Alright, that is what we are trying to say, is that every element under X, the element of X are what we call the domain, while the element of Y are what we call the codomain. Alright, so every element of this X, that is the element under this X, must have only one element that they are mapped to under the codomain. That's exactly what we are trying to say. Alright, so this is what I'm trying to say. Let's say f of 1 is equals to 2, f of 3 equals to 4, f of 0 equals to 3. Alright, this is one-to-one function. This is what we call injective function. And the structure will look like this. That is, you're having x, you're having y. This is 1, 3, 0. And this is 2, 4, 3. That is, this is mapped to this, this is mapped to this, this is mapped to this. So these are what we call the codomain. Elements here are what we call the codomain. And elements here are what we call the domain. So according to the definition I gave to you, I said every element of the domain must have a distinct image in the codomain. That is, polygamous family is not allowed. Let's represent this family, that this X, they are all male, and this Y, they are all female. That is, every man here must have just one wife under Y. It's not allowed that bro Tai here will have another, we have 2 wives here. Even, let me say, whenever you're having an element here, let's say 1 is now mapped to this, is mapped to this again, that's not a function. That's one to many, and it's not a function. So it's not allowed that an element here will stay, that is 1 mapped to 2, 1 will also mapped to 4. That's what we call one to many. Alright, and it's not a function. So now, every element here, you can see that they have distinct image, that is, they don't share any other image together. And let me show you a property of this injective function. Property now. The first property is that f of x is equals to f of x1 is equals to f of x2, and this implies that implies that x equals to x1 equals to x2. Alright, f of x1 equals to f of x2 implies that x1 equals to x2. Alright, and the other one is that if f of x1 is not equals to f of x2, this implies that x1 is not also equals to x2. I would like you to have this at the back of your mind so that you understand this concept very well. Alright, this is all about injective. Now we're moving to surjective function. Okay. Alright guys, so now I'm moving to surjective function. Surjective function. I said you can also call it onto function. Don't forget, they are the same thing. Surjective function Alright, so this surjective function says that every element under the codomain must have at least one pre-image under the domain. Must have at least one pre-image under the domain. Alright, that's cool. So when we are talking about this, let me give you the definition. Every element of the codomain must have at least one pre-image in the domain. Look at this word. I underlined another one which I said at least one pre-image. You can see this word is different from these things that we make use of in the injective function. So when you are dealing with surjective function, every element of the codomain must have at least one pre-image in the domain. We said at least, that is at least, not distinct this time around. Alright, so this is what I'm trying to say. If you're having f of 1 equals to 4, f of 2 equals to 3, f of 4, what is it called? F of 3 can be equals to 4. F of 3, let me check. So this means that we are going to have x1, y4, x2, y3, x3, y4. Alright. So this is what we call a surjective function. All the elements in the codomain must have at least one pre-image in the domain. This is marked to this, this is marked to this, this is marked to this. Alright, must have at least one pre-image in the domain. And this is one of the beautiful properties for this also. The property says that whenever f of x must be equals to y, f of x must be equals to y. Alright, you might be wondering what I'm trying to say there. Don't worry, when I get to the examples, you will understand better. Alright, let's move on to many-to-one function. Many-to-one function. Alright, many-to-one function now. Alright, many-to-one function now. Under this many-to-one function, don't forget that there is nothing like one-to-many function. That is, this is what I'm trying to say. You're having x and y, and you're having 1, 2, you're having 3, you're having 4, you're having x, you're having a. This will never happen. This is not a function. But this is allowed. You can have 1, 4, you can have 2x, 3a. That is, this is marked to this. This is also marked to this. This is what we call many-to-one function. Are we together now? But let me show you exactly what I'm trying to say. Assuming I'm having f of 1 equals to a, f of 2 equals to x, and f of 3 equals to a. So this will look like this. You're having x, you're having y, that is, you're having 1, 2, 3, ax, a. I can write a, but I may decide to leave it like this. So I'm having this to mark to this. This is marked to this. Sorry. And this is now marked to this. This is what we call many-to-one function. Many-to-one function. Why? Because we're having 1, 2, that's 2 elements. That's many-to-one function. In fact, all of them can be a. If all of them is now a, I will be having 1 that is x, y, 1, 2, 3, and a. This will mark to this, this will mark to this will still have mark to this. It's a function. That's what we call many-to-one function. I hope you guys are understanding what I'm trying to say now. Alright, that's cool. So let me quickly move to bijective function. Bijective function. Bijective function. Bijective function. Alright, so under this bijective function, this is a variable concept. This is a variable concept. Under this bijective function is a function that is both injective. This is a function that is both injective and surjective. That is both injective and surjective. So once a function is both injective and surjective, we said that that kind of function is bijective. Alright, so that means that if you have an f of 1 and f of 2, having f of 3 equals to, let's say, a, b, c. And the structure will look like this: x, y. We're having 1, 2, 3. We're having a, b, c. Alright, this will map to this, this will map to this, this will map to this. This is what we call a bijective function. Because if you look at this follow the protocol for a one-to-one function, and also follow it for the surjective function. That is, every element of the domain, if you want to check it for the injective function, every element of the domain is having a distinct image in the codomain. 1 is having a distinct image, 2 is having a distinct image, 3 is having a distinct image. And for the second one, the surjective function says that every element of the codomain must have at least one pre-image in the domain. A is having at least one pre-image, B is having at least one pre-image, and C is having at least one pre-image. So that tells us that this kind of function is bijective. And this is the property. This is the property. The property 1 is that f of x must be equals to f of x1 must be equals to, or let me say f of x must be equals to f of a, implies that x equals to a. The same thing as f of x1 and f of x2 that I made use of in the first illustration I gave to you. So f of x must be equals to f of a, implies that x equals to a, and once the f of x is not equals to f of a, this implies that x is not equals to a. And the second one, that is the properties for the surjective, that is f of x must be equals to y. Once it obeys all these properties, then we say that the function is bijective. Alright, that's absolutely cool. So now I would like to give us some illustrations, some examples, and we solve it together. Alright, let's move on. Alright guys, so now let's say example 3, example 3. Let's say our f of x equals to 2x minus 3, 2x minus 3. If our f of x is 2x minus 3, given, okay, let's say which type of function is this? Which type of function is this? Alright, we have our f of x to be this. So which type of function is this? Alright, we can decide to pick any number. That is, let's make use of f of 1, f of 3, f of negative 5. Alright, so f of 1 will give us, that is f of x equals to, f of 1 equals to, 2 into 1 minus 3, 2 into 1 minus 3, which is equals to negative 1. F of 3 will now give us 2 into bracket 3 minus 3, and this will give us what? 6 minus 3, which is 3. And f of negative 5 will be 2 into bracket negative 5 minus 3 equals to 2 multiplied by negative 5 will give us negative 10. Negative 10, negative 3 will give us negative 13. Alright, so these are the inputs and these are the outputs. If you look at this now, for every input we are having a distinct image. For every input, we are having a distinct output. I guess what I'm trying to say. We are having a distinct output. So this kind of function is said to be injective. And if you look at this now, the image will look like this: x1, 3, -5, and we are going to have y, -1, 3, 13. You notice their output, that is, this is mapped to this, this is mapped to this, this is mapped to this. So this kind of function is said to be injective. It's said to be injective. But note, this is injective. Let's check if it is also bijective. That is what the property for it to be bijective, that is f of x will be equals to y. And this implies that, you know, let's say this is our f of x, or let's say that's our y now, y equals to 2x minus 3. If we collect the like time now, we are going to have, this implies y plus 3 equals to 2x. And if we divide both sides by 2, this implies that x equals to y plus 3 over 2. Alright, so let's come back to this function now. If we come back to this function again, f of x equals to this, we are now saying that this implies that f of x equals to, you know, this is our value of x now. I will insert it here, so I'm having 2 into bracket y plus 3 over 2 minus 3. Alright, so now if you want to open this bracket, you are going to have this tell us that we are going to have 2y plus 6 minus 6. 2y plus 6 minus 6. And this will cancel this. This will cancel this. Alright, so we are going to have 2y. That tells us that f of x is equals to 2y. And we said that f of x must be equals to y. That tells us that this function is not surjective. It's not surjective. This function is not surjective. And since it's not surjective, that tells us that it is not bijective. So this function is only said to be injective. Alright, that's cool. Let's look at another example. Alright, now let's say our f of x is equals to x to the power of 3. X to the power of 3. So now do we know if this kind of function is injective? Let's say now when our x is 1, we are going to have f of x, that is y equals to x to the power of 3. That means that we are going to have y into 1 raised to the power of 3. We obtain what? We obtain 1. When x is 2, we are going to have y into this, that is 2 raised to the power of 3, which is equals to 8. When x is now 4, we are going to have 4 to the power of 3. And 4 to the power of 3 is still 64. So this kind of function, we can say is also injective. But let's check if it is surjective, because for every input we are having another output, a distinct image. That is, we are not having the same output for two inputs. So let's check if this function is also surjective now. Equals to x to the power of 3. This is y equals to x to the power of 3. Alright, so now if we look at this, we can find the cube root of both sides. This means that cube root of y equals to x. Alright, so if we said x is equals to cube root of y, I'm going to come back here. So I'm having f of x equals to, now our x is cube root of y, so I'm having cube root of y to the power of 3. And this power can cancel the cube root, so I'm going to have f of x equals to y. Hence, the function is said to be surjective. So once the function is said to be bijective and injective and surjective, so I can say this function is what? Is bijective. Alright, absolutely cool. Let's check another example before we call it a day. Let's check another example. Let's say my f of x now is equals to 1 over 2x or 2x minus 3. Oh, sorry, let me give you this one. Okay, so let's say our f of x is equals to x squared. Alright guys, can you tell me what we are going to have? Is this function bijective, is it injective or surjective? Alright, if we are having this now, let's try it. That means that when our x is 1, we are going to have y equals to 1 to the power of 2, which is equals to 1. When our y equals to 2, we are going to have x equals to 2, 2 to the power of 2, which is 4. But let's look at something. Guys, when our x is equals to negative 1, what are we going to obtain? We are going to have y equals to negative 1 to the power of 2, which is equals to 1. Alright, now if you look at this kind of function, you can see that we are having different inputs with the same output. Which type of function is having that kind of property? Which kind of function is having this kind of property? Different input is having the same output. That is, 1 is having the output 1. The negative 1 is also having the output 1. So this is said to be subjective. This is a subjective function. Alright. This is a subjective function. That's cool. Let's look at another example. Now. So if f of x is equals to 1 over s squared minus 4, 1 over s squared minus 4, is this kind of function, oh sorry, I want to make use of s cubed, or let me say 2x, 2x minus 4. Is this kind of function said to be injective? Is it said to be injective, bijective, or surjective? Let's check. When the value of x is 1, when x equals to 1, we are going to have our y to be equals to 1 over 2 into 1 minus 4, which is equals to 1 over 2 minus 4, which is equals to 1 over negative 2. Okay? When x equals to 2, we are going to have, this implies that y equals to 1 over 2 into bracket 2 minus 4, which is equals to 1 over 4 minus 4 is 0. The function is said to not be defined at this point. The function is not defined at this point. Let's say our x is now equals to 3. We are going to have y equals to 1 over 2 into bracket 3 minus 4, which is equals to 1 over 6 minus 4 will give us 2. Alright. Now, you can see that, okay, you can see now that this function is injective. But is it said to be subjective? Let's check also. Is it subjective? Don't forget the properties that for it to be subjective, f of x must be equals to y. Alright. Let's say I'm having now f of x is equals to this. So that tells us my y equals to 1 over 2x minus y minus 4. You know, I said f of x will also be represented as y. Alright, so now let's do something like this. If I cross multiply, this will be y into bracket 2x minus 4 equals to 1. Alright, so now what am I going to do? So this tells me that for me to obtain the value of y now, I can say this is 2xy. I don't need to expand the bracket. So for me to obtain the value of x, I can say this is, okay, 2xy minus 4y equals to 1. And this will say that I'm having negative 2xy equals to 1 plus 4y. And if I divide both sides by 2y, I'm going to have x equals to 1 plus 4y over 2x. Alright, over 2y, sorry. Over 2y. That's cool. So this is the value of x. Let me now come back to this function and insert this value there. So that means that I'm having f of x equals to 1 over 2 into bracket 1 plus 4y over 2y minus 4. Alright. So this implies that f of x is equals to 1 over, if you use 2, these 2 will cancel these 2. I'm having 1 plus 4 over y minus 4. Alright, this also implies that f of x is equals to 1 over, this will now be 1 plus 4y minus 4y over y. And this implies now that I'm having 1 over 1 plus 0 over y, and this implies that f of x is equals to 1 1 plus 0 is 1, so I'm having 1 over 1 over y, which is same thing as what 1 multiplied by y over 1. And this will give me what? Y. So therefore, f of x is equals to y. And once f of x is equals to y, that tells us that the function is both injective, the function is surjective. And the function we have already checked it, and the function is also injective. So that tells us the function is bijective. Alright, that's good. But I would also like to show you another concept, what we call a range, before we call it a day. Alright, so I want to show us a range. A range. What do we call a range? A range is a subset of the codomain. A range is a subset of the codomain in which the element in the domain is mapped to. In which the element in the domain is mapped to. This is what I'm talking about. Is a subset. This is a subset of the codomain in which the element of the domain is mapped to. Alright, so let me give us an illustration. This is what I'm trying to say now. Assuming we're having, let's say, f of 1 equals to 3, f of 2 equals to 1, f of 3 equals to 0. You know the image is now, the structure is now x. Under x we're having 1, 2, and 3. Y we're having 3, 1, and 0. This is mapped to this, this is mapped to this, this is mapped to this. All these are what we call the range. They are called the range. Now, you can see that every element under this, which is also set y, they are all the range, because a set is a subset of itself. Alright, let's look at another one. Let's say I'm having f of 1 equals to, okay, sorry. Let me give us another structure. We're having x equals to a, x, y, and our y equals to 1, 2, 4, 6. So the element under x is now 3, while the element under y is 4. Let's say this is mapped to this, this is mapped to this, this is now mapped to this. So the range here now are what? 1, 2, 6. Alright. Let me give us another illustration. X, y, I'm having 1, 2, 3, I'm having 3, 2, and 3, let's say 0. This is mapped to this, this is mapped to this, this is mapped to this. So the range here are just the element that this element of x is mapped to, which are what? 2 and 3. Range equals to 2 and 3. Alright guys, so this will be the end of today's class. If you like this kind of video, like, subscribe, invite your friends to my channel. So see you next time. Thank you.